We're going to go ahead and take a look at number 65 from section 1.7, which deals with inequalities. So 65 is x squared minus 3 is greater than or equal to 0. With problems such as these, they're actually kind of nice. When you don't have the middle term, you don't have to work as hard to isolate x, or your variable in this case. Because notice that x is only occupying one of your terms. Everything else is free of it. So one of the first things that can be done is we can start by isolating x by adding 3 to both sides. And this gives us x squared is greater than or equal to positive 3. And the next thing that we need to do is we need to figure out how to get rid of the square in order to isolate x entirely. Well, if we hit both sides with the square root, that will cancel the square and the square root because they're inverses of each other. And that permits us now to say that x is going to be greater than or equal to plus or minus root 3. Make sure that you don't forget the plus or minus sign, because if you drop the minus sign in this case, you're only providing half of the solution. So from here, we can go to our number line, and we know that we have a negative root 3 and a positive root 3. Okay? So one of the other things that we can note here is that the circles that we will have over them will be closed because we have an equal sign that's included in our inequality of greater than or equal to. So now we can go ahead and jump right into sign analysis. Okay. And what the sign analysis is going to tell us is basically where should I be shading. Okay. So, and you want to start off by working with the original problem that you were provided. So maybe you're not sure what the square root of negative 3 would be in this case, and maybe you don't have a calculator available. So what I would suggest doing is work with perfect squares to kind of figure out what numbers you should work with. So in the case of negative square root 3, well, we could say that, well, let's talk about the square root of 3. Well, we know that the square root of 1 would be to the left of the square root of 3, so because it's smaller, and the square root of 4 would be to the right of square root of 3 because it's bigger. And we know that the square root of 1 is equal to 1, the square root of the square root of 4, I'm being redundant, is equal to 2. Okay, so maybe what would be a good idea then would be to say, in the case of root 3, I'm going to pick 2. I know that 2 is to the right, so 2 is somewhere in here. So it would be a safe place to check. Okay, so if I put 2 in for x, it's going to give me 4 minus 3 is greater than 0, or 1 is greater than 0. And that's true, so that side will give me a true statement. That being said, I can do the same thing on the left side of negative root 3. So if I use, instead of a positive 2, a negative 2, because negative 2 is going to be found somewhere out here, and I were to perform the check, I would still get negative 2 squared as a positive 4. And I get a true statement again. So I would be able to shade this area. Now, odds are, since in these situations when you're dealing with quadratic inequalities, you're probably done. If you really want to check your work, let's say we pick 0 as our test x value. So if we put 0 squared in, because 0 would be between both the negative root 3 and the positive root 3, we would have 0 minus 3 is greater than or equal to 0, or negative 3 is greater than or equal to 0, which that's not true, so I'm not going to shade there. So my interval then will go from negative infinity to negative root 3, but we want to include that because of the inequality that we're working with, that greater than or equal to. So we want to include that value. We're going to union it to hop over that dead space that's happening between the two roots, and then we're going to pick right back up with root 3 to positive infinity. So there are your two solutions. And there you go.